Hello everyone. Today we will learn about the diffusion and diffusion current. The diffusion is a natural process. The migration of charge carrier from higher concentration to lower concentration is called diffusion, or higher density to lower density. So this is the definition of this diffusion. Diffusion mainly due to the concentration gradient. Suppose that we are concentration gradient means dy dx. The slope is called gradient. So you are considering the electron concentration, it means dn by dx, or you are considering the whole concentration, it means dp by dx. Okay. So for the semiconductor materials, movement of we are considering the semiconductor material and n-type material or p-type material. It means migration from higher concentration to lower concentration having the some length of this diffusion. L is the length of diffusions. Okay. So diffusion mainly flow in the semiconductor materials. In semiconductor material, diffusion is due to unequal distribution of the charge carrier. This is the most important thing. How can diffusion justify? Suppose that in case of the semiconductor material, only diffusion process exists. So diffusion why not occurs in case of the metals? This is the reason. In metal, electron concentration is very high and is equal to 10 to the power 28 per meter, and therefore electron are arranging in equal distribution manner. So diffusion cannot place in case of the metal. Diffusion only occurs in case of this semiconductor material. So length of, we want to calculate the length of diffusion. L is equal to root of d tau. So d is the diffusion constant of charge carrier, tau is the carrier lifetime. So suppose that we are taking the length of diffusion is the average length. So d is equal to diffusion is equal to mu into V2. Mu is the mobility and Vt is the thermal voltage. So we can putting the value here, L is equal to root of mu V2 into tau. So length of diffusion depends upon four parameters: diffusion constant of charge carrier, mobility of charge carrier, number 3 carrier lifetime, and the 4 is temperature. Electron diffusion length is ln is equal to root dn dot tau n centimeter, length in centimeter. Whole diffusion length Lp is equal to root of Lp dot d tau p centimeter. So you want to calculate this now. Electron diffusion current density J is equal to Jn diffusion is equal to q dn by dx. This is the gradient diffusion constant of for the n-type materials, and this is the charge. So whole diffusion current density is Jp diffusion minus q dp by dx. So this is the electron diffusion current density, whole diffusion current density, and electron diffusion current as like as the In is equal to In diffusion is equal to Jn diffusion multiplied by area. I is equal to J into A. J is equal to I by A. So we can calculate the current. J is equal to I upon A. So we can calculate I is equal to J multiplied by A. So you can calculate with the help of this electron diffusion current diffusion current. So this is define the electron diffusion current density for the electron diffusion current density for holes, and electron current diffusion currents. Whole diffusion current is denoted IP diffusion is equal to Jp diffusion multiplied by area. So I is equal to J into A. So we can represent it the diffusion constant current IP diffusion is equal to Jp diffusion multiplied by area. So total diffusion total current density in semiconductor is equal to Jp plus Jn. So this is the Jp as the diffusion current density of the hole, and Jn is the diffusion current density of the electron. So we can calculate the Jp and Jn. So Jn we can calculate with the help of this formula, Jp diffusion plus Jn drift. Okay. So this is the most important things, and similarly we can calculate the current density for the four holes. So Jp is equal to Jp drift plus JP diffusion. So you can say that suppose if we want to calculate the current density for the electron. So electron we can replace with the diffusion current density of the diffusion Q du1 dny dx plus this drift Q n mu n an electric field. So we can similarly we can calculate JP current density for the holes. JP drift plus JP diffusion is equal to JP. This drift is represented as PQ mu P into E or minus Q dP dpx by E. So this is the sum terms. Dn is the concentration gradient for this electron. So similarly dP is the concentration gradient for the hole. So dP is the diffusion constant for the electrons, or mu P is the mobility carrier for the mobility. dP is the diffusion constant for hole. Mu P is the mobility carrier mobility for the holes. So P is the number of holes, and so we can use this formula. We can calculate the total. This J is equal to JP plus Jn. So one thing, drift current is depends on the some parameters, some factors to the carrier concentration, charge, mobility of charge carrier, and field intensity.